So today we are going to. So I've already thrown new homework for you guys online. Okay. So in other words, I've already posted the assignment that I would have posted tonight. Went ahead and posted that. Now you might be asking, oh God, the professor just assigned something. Does he realize that spring break is next week? Is he going to come to the classroom thinking that that there's class next week? No, I am perfectly aware that spring break is next week, and I expect you to work on my homework exactly as much as I expect to work on my classwork, which is maybe not at all, right? So I have the proper expectations of students there. Okay, in all honesty, I'm probably going to do some preparation just so we're going to transition to flip lectures after this lecture, or transition to more of those. But anyway, as a result, your homework that I just assigned isn't due during spring break. From my perspective, the week of spring break, which is this 4th through 10th, that doesn't actually exist, okay, from my perspective. So your homework that I just posted is due on basically, well, if it's due after the next lab, which would be basically Saturday the 17th. So this isn't a particularly hard assignment. It doesn't require 2 weeks of work. I'm just assuming you're not really going to work on it. That being said, when we get back, we're going to do more in-class exercises. Also, the content that we're covering is pretty new today, which is arrays. So we're going to cover arrays today. First, we're going to go over why do we need arrays, and then we're going to go over what are arrays, and then we're going to go over the basics of how we construct arrays and stuff. So to get into the whole why do I need arrays, and I still haven't told you what that is, right now. So basically the next couple of the rest of the semester is basically decrypting all the stuff in public static void main, meaning what the heck, we've already learned what void means. Main is a method that doesn't return anything, and we know that args is an argument and it's string bracket. So today we're going to learn what those brackets are. Then after that, once we get that done, we are going to figure out what the heck public static means and public over here as well. So, and what the hell's class, So all this stuff we're going to figure out and decrypt it and make it understandable. But for right now, we have to go through and basically show you what kind of problems are we going to have trouble solving right now. So let's go ahead and do system. So let's write a basic program. This is basically a let's see. Also, you should be getting your grades back during your lab. So those should be handed back to you. So let's make a basic program that occurs to me like that tallies up the grades. Okay. So let's go ahead and tally up the grade, like make a program that maybe tallies up the grades that for your, in the class. So suppose I want to figure out something like the average grade that everybody that we submitted, right? So first thing I'll do is maybe I'll write a program that goes, system.out.println enter grades of students. I will give you the average score. Or maybe we'll start out. Actually, well, let's move up to the average. So min, max, and average score. There we go. Big believer in the Oxford comma. Okay, so that's what a program's going to do. So to do this, we just need to, we'll create a scanner. Scanner KB, because we're going to be reading from. We're not going to be using it to read a file. We're going to be using it to enter stuff. It's equal to new scanner system dot in. Okay. So So let's see, system.out.println, enter the word exit to quit. Now, there were some stuff that I left off in Chapter 6, like that whole throws and the try-catch, and I said I'd get back to them. But honestly, it's that stuff that I like to get back to at the later end of the semester, because that stuff takes a half an hour to teach, and I'd rather teach you this first. It's not so important for right now to tell you how to handle your program crashing. Right now, that's come later. So let's go ahead. So let's go ahead and do, KB. So string input is equal to kb.nextLine. Input dot equals exit, or so while our input is not equal to exit, what are we going to do? We're going to take our input, which is a string. We're going to go ahead and turn it into an integer. Int score is equal to input right? We learned how to turn things into integers. So integer.nextInt input, or not extent. I'm thinking of randomness right there. So parseInt. So we turn that integer into an input. And now int. And so now to calculate the, let's go ahead and figure out how do we do the max. How do we calculate the max? Well, we'll have an int max over here, which is equal to like -1 or something, and then int min is equal to 999. Basically, I'm using basically we're keeping track of the minimum and maximum scores here. Okay, and the idea here is that maybe if score is greater than our maximum, then that's the new largest score, right? So why did I set max equal to -1? Well, because we're dealing with scores that students are scores that students scored on exams, right? That's typical. I haven't seen a student get a negative score yet, right? But I suppose things are possible. But I somehow doubt that students ever get a negative score on our exams. So that's why I said -1. So if the score is bigger than the maximum, then that score becomes the new maximum. And if another similar if statement, if the score is less than our minimum score, right? If it's smaller than the smallest score we found so far, that's the new score. And similar reason why I set minimum to the initial minimum value to 999, right? It's because I want to I want to figure out how many so if I set the score to equal to 999, then basically any value is going to be smaller because students really probably will only get a 105 at maximum on their exam. So it's just the way it's going to work out. All right. But what about figuring out something like the average, right? Well, to do that, I'll have to keep track of the number of inputs. Oh, and first off, I'll have to get in another kb.nextLine over here. So at the end, so to calculate the average, I'll have to do something along the lines of int total is equal to 0. Total plus equals score, and int num inputs is equal to 0. Num inputs plus plus. So basically what we're going to do is that we're going to add every time we see, in order to calculate the score, that's just the average score. We would want to add all the scores together and divide by the number of scores we had. So that's what we're doing here. We're adding all the scores together, then we're counting how many scores the person inputted, and then we're going to divide by the number we had, right? So system.out.println, if I wanted to, so I could print out min now, and then the maximum, and then the then let's go with the total divided by num inputs, which will be an integer value because I'm dividing by an integer by an integer. So let's go ahead and see. So let's say somebody got a 90, an 80, a 100, and let's type in exit. So 80 was the smallest score, 100 was the biggest, and 90 was the average. And that kind of makes sense, right? So 90 plus 100 plus 80 is equal to 270. Divide by 3. That gives, is equal to, 270. Divide by 3. That gives us 90. So that makes sense. That works out what we're thinking. And this works pretty well. So now here's the nasty problem I would ask. How would I calculate the median score? So first off, what is the median? The median score is basically the middle value, is basically given a range of scores, which one falls in the middle. And it's one of those very easy problems that are very easy for us to solve, right? You just look at all the scores together and go, that one's in the middle, right? Or you sort them and you go, that one's in the middle. So how do we do that? So we've got a bit of an issue, right? So first off, you can't calculate the median unless you know how many items there are. Okay, that's issue number one, right? You can't really maybe there's a way to calculate the median, but it involves or do a running median. But let me tell you, the math on that is hard. Okay. So first thing I need to know is I'd probably have to ask the user how many scores they would want to input. Okay. So instead, what I'd do is that I'd say scanner. I'd probably have to ask them over here, system.out.println. How many values do you want to input? Right? Okay. How many values do I want to input? Right? And then I'd want to put out 8. Maybe I'll say ask the user and they'll put in 8. Well, the question is, how do I store all those values so I can compare them, so I can go through them and find out what the median is? I mean, I can't create multiple variables. I can't create a for loop that creates like 6 variables at once, or 8, or however many the user inputs, right? Or let's generalize this even further. Okay, let's scratch the median for a second and say, what if we wanted to do something along the lines of suppose we want to do something along the lines of, well, what if I'm not just interested in the highest score? That doesn't really tell me much because the highest score is always going to be 100, right? There's always that student who always aces the exam. I'm interested in maybe the 5th highest score in class. That gives me a better representative of the students that, there's always 5 students who already know the class when they come in. But maybe after the 5th student, that's when student I can tell, because after that point, the students don't necessarily know everything, right? So how would I figure out who the 5th highest is? Well, to do that, I'd have to keep track of the 4th highest, the 3rd highest, the 2nd highest. See where my problem is? I have to keep track of all the values that I'm inputting, right? And that's a bit hard, right? I can't just do, I suppose I could do, okay, int x is equal to, so int first score, right? Or score 1, right? I could possibly do this, score 1, score 2, score 3, right? And score 4, and so on and so forth. And maybe until I got bored and got up to 100 or something, right? That would take a lot of time, though. Okay? And furthermore, my program would fail once I went above that allotted number, right? Wouldn't really help me out there, right? Because one of the other lecture sections, they teach 160 students, right? So going up to 100, this program would fail, So we need something that basically we need a way of creating a bunch of integers all at once and grouping them together. And that's where arrays come in, okay? So let's go ahead and see what we can do with an array. Let's go ahead and rewrite this program and see what I can do with it. So enter the grades of students. I will give you the min, max, and average score. Enter the word to quit. Exit to quit. System.out.println. First, tell me how many students you need. Entering. Okay, so the first thing we'll do is tell it how many students we're entering. So we'll go system, we'll go int num students is equal to, let's go with, I'm going to do this in one line, integer.parseInt. Yeah, so first off, I got to move this down. KB.nextLine. So get used to this with me starting to do function calls inside function calls. This just means that I'm getting the input from the user, taking that string, the resulting string, and immediately throwing into the integer.parseInt. That looks scary, but and honestly, you really shouldn't do it for more than just this, where basically you're just having one function call inside of another function call. Any more than that, it becomes hard to read, and you should probably just split it up like line by line at that point, right? Say, like, have an input and then put the input into there. But doing it so where it's only like nested once like that, that's okay. Again, readability is king here. So now what we're going to do is that since we know how many people we're going to enter in, we're going to create a bunch of integer values all at once, a bunch of integer variables all at once, okay? And they're going to be stored in something called an integer array, and that looks like this. So integer array. That's bracket and bracket. So it's the curly brace key, but without pressing shift, okay? So we name it just like another variable, and we'll call it scores. I like to pluralize these things, right? Rather than calling it a single score, I'm going to call it scores, right? To represent not groups of 20, but because that's what a score is, but plural, 20, a bunch of whatever the student's scores are, And then basically we say, okay, how many integer, so this denotes I want a bunch of integer values. That's what this declaration is. It says, get ready to basically somewhere in memory hold a bunch of integer values together, okay? And we're just going to group them together. It's going to be like just a bunch of blocks of memory all adjacent to each other, and we're going to be able to work with them as though they're one variable, okay? Then the next thing is, how do I actually create this thing, right? Well, I use the new keyword. Scores is equal to new int, and rather than using parentheses or anything here, and don't feel bad if you have to look this up a bunch of times, right? I swear to God, every single time I came back from summer break during my bachelor's degree, I had to look up how do I create an array again in Java. It's not so hard. You just go new, the type of the array you're creating, which is int in this case, and then how big you want it to be. And we want it to be num students big. So num students, okay, integer.parseInt. So basically here, if I put in 5, this will be 5. Basically, we'll have 5 variables to hold score. We'll have, if I put in 10, it will be 10. If I put in 20, it'll be 20. And if I put in -1, it will yell at me very hard. So, okay. Next, what I do is, and I'm sorry if I'm making you rewrite this completely, we'll get our inputs. We don't need this whole exit to quit anymore. Instead, what we'll do is that we'll just simply do a for loop over here instead, because now we know exactly how many students that we're going to be putting in. So for int I is equal to 0, I is less than So I'm going to go through this and present a working program, and then I will go back and explain a lot more of the basics, okay? So I'm basically giving you the high-level view of this. It's going to look terrible and intimidating, and I apologize for that, but I just want to show what you can kind of do with this. Okay. And then I'll show you the how we can basically make it better, or I'll explain how this works. Num students. Right? We want this to run, this loop to run num students number of times, I++. So this, okay. String input is equal to the next line. Int score is equal to, I'll call it this score is equal to input. Right, so we're going to get this student's current score from the user, and then what we'll do is that we will take that and we're going to store it in the array using something called bracket notation. I is equal to, let's see, it's equal to this score. Okay, so now we've read in all the values, and now we can do all the analysis that we want on it. Let's go ahead and say, so here what I'm going to do is I'm going to do a couple nifty cool tricks. Arrays dot sort our scores. So we're going to sort our scores, and then let's go ahead and say system.out.println. And I will go. I swear to God, I will go back and explain all this. So eventually this will stop being a mystery. Right now, it's going to look like an overwhelming mystery. But I swear, I wanted to get a working, more complex program, so you'll have that as an example. So print out scores, index 0. Print out scores. What is this gibberish he's running in? Suddenly, it's becoming intimidating looking, right? Scores. Dot length -1. What? So this will print out the minimum and the maximum of, let's say, 5 students. So 5 students, and now let's put in 3. That's a terrible score. 90, 91, 42, and 5. So it says our lowest score was a 3, and our highest score was a 91. If I switch the 0 to a 1 though, and this to a -2, if I put in the score, if I tell them I want 5 scores, and we put in 1, 2, 3, 4, and 5 for our scores, it's going to print out 2 and 4, which are our negative, which is basically our second lowest and our second highest scores, respectively now. So now that I'm storing these data, this data, and I'm sorting it over here, that's pretty nice. I can do a lot with this. So what the heck is this? This is an array. So first off, now you know what this is. This means that I'm dealing with a string array over here. So let's go ahead and jump into the slides and see what they have to say about all this gibberish. Okay. So documents, slides. Chapter 7, arrays, right? We didn't finish all Chapter 6. I just gave you what you needed to know about Chapter 6 in order to survive. We'll go back there because arrays basically is it's the chapter that takes the most amount of time, right? We're spending about a week on every chapter. I'm not going to be surprised if we spend maybe 2 weeks on arrays, especially since you're about to come back from a week-long break, so I'll probably have to reteach you anything, which is why I'm going over a high-level view now, because you're going to be getting it twice. So, right, here they did a similar program. Can we solve this program? Let me get rid of my face. So how many days temperatures? You want 7 days worth of temperatures. Enter all 5 temperatures. It calculates the average, and it tells you 4 days were above average. So in order to do that, they needed every single value twice. They needed it to compute the average, right? And once they computed the average, they had to compare all the values to see how many of those were above average. This is similar to the problem we needed here, where I was asking how could I calculate the median? Or how could I figure out what the second highest was? I would need to store all the values a bunch of times and be able to refer to them a bunch of times. We could read every value into a variable, like I was saying. We could make a bunch of variables, but we don't know how many we need until the program runs. And we don't know how many variables to declare, right? I don't want my program to be 200 lines of me making x's that I may or may not need, right? Score 1, score 2, score 3, score 4. I don't want to do that. So we need a way to create a bunch of variables in one step. We want to store a bunch of data together. So arrays seem like I've made them seem like this hard thing, but fortunately you've been dealing with them the entire time that you've been working with strings. Okay? Strings, right, are these weird, interesting things, right? And they seem to like completely obviate the need for a character, right? We have the character primitive, and we pretty much never use that, right? Unless we're doing the extra credit assignment, in which case we totally need them. But instead we work with strings if we're dealing with letters, right? So strings are, at their core, they're just simply arrays of characters. They're a bunch of characters grouped together. So we're going to be discussing arrays, and it's going to be a heck of a lot like dealing with strings. And so long as you understand that, and so long as you're comfortable with dealing with strings, it's not going to be too bad. So an array is an object that stores a bunch of values of the same type. Okay? So we have two terminologies. The index, which we already know. We already know about the index, right? In strings, that was if we've got the word hello, H is at index 0, E is at index 1, L is at index 2, L is at index 3, and O is at index 4, right? H-E-L-L-O, okay? It started from 0 for reasons that I'll actually explain this lecture, as opposed to 1. Although in some languages, arrays do start at 1, like MATLAB most notably. So what we say is that each of these, that if we create an array, so this is how we visualize an array of integers. This is an array of integers, and we say that element 0, that means the element at index 0, its value is 12. The element at index 4, its value is 5. The element at index 9, that value is 3. We use element because we don't necessarily, if we're just generally talking about arrays, because if we're dealing with integer arrays, we'd be saying the int at index 0, the int at index 4, the int at index 9. But if we're dealing with an array of doubles, we'd be saying the double at index 0, the double at index 4. So element is basically that value could be any type we want, right? But arrays, when we create them, it's all going to be the same type. So this array is of size 10. Okay, the array is of size 10, and it's got 10 values, 0 through 9 in it. Okay, those are the indices. How do you create an array? Okay, how do we create an array? We go the type, so you do it just like you were doing anything else. So if I was creating a single integer, I'd go int x is equal to 5. Okay, here we go int brackets a bunch of x's is equal to a new integer, and then we say how big we want it to be. So the example here is integer numbers is equal to a new integer of size 10. And this creates a new integer array of size 10. It creates 10 integers for me. Now you'll notice that there's a bunch of zeros over here right now, right? This is all a bunch of zeros. And this is because when we create an array, Java needs something to put in those, it makes space for them, right? So it needs something to put in that space. So what it does is that it puts in a 0 value by default. So for integers, that's 0. For doubles, that's 0.0. For booleans, it's a bunch of falses. If it's a bunch of strings, it's going to be nulls because that's how we represent a bunch of strings. We'll explain what nulls are in better detail when we go into objects. You can create arrays of anything. You can create arrays of strings, arrays of integers. You can create arrays of scanners. Okay? So there's all sorts of things we can do. So the length can be anything we want to put in there, any expression. So here, int x is equal to 2 times 3 plus 1. 2 times 3 plus 1, so 6, 7. And then we would want to put And then int data is equal to new int of 7 mod 5. So that's 2 plus 2. So this would create a new array of size 4. Although I highly recommend you don't do something like this because that looks confusing. And again, as I mentioned, every array gets essentially a zeroed out value by default. So let's see how these modify visually, and then I'm going to start showing you guys how to encode how we modify these things. So, okay. Yep, we do a bunch of stuff there. Okay. So there's two things you can do. You can basically get an element and you can set an element. You can get the value and you can change the value here. So for example, so suppose we start out with the array looking like this. The first thing we do is we'd say number 0, the number at index 0. We're going to store the value, and then remember, this is how you read it. You take the value on the right and you store it in the memory location on the left. So 27 gets stored in index 0 of numbers. Negative 6 gets stored in index 3. So, right, 27 will be at index 27, negative 6, 27 will be at index 0, negative 6 at index 3. Then we can print out, then this will run system.print line number 0. So this will retrieve 27. And if numbers negative 3, this will retrieve, numbers 3, this will retrieve negative 6, is less than 0, it'll print out element 3 is negative. So let's go ahead and actually do some coding on that and see. So array basics. So let's go ahead. And we're going to deal with the integer arrays because honestly they're the easiest to work with. They're also the best for making test questions because indices are also integers. So first, int x. So int nums. I'm going to use int nums because it's a bunch of numbers. And I suppose, I'm saving you 6 letters here. 3 letters now. Int nums is equal to new int of size 10. So first off, I suppose the first thing you want to do is, right? So I made a mistake here. What was my mistake? Yeah, I forgot the brackets. Somebody held up their hands in a very correct manner. So int nums. I forgot the brackets around there, so just remember those. But your compiler warned you. And I suppose now I want to print out the nums to make sure I just understand that it works, right? Just to see it, right? Let's go ahead and print it out. What in the blazes? Right? What's that gibberish on my screen? It says bracket I at the @ symbol 435566938. Run it again. It does the same thing. What in the world? Okay, maybe if I change the size. No. Same thing. What is this? Well, what it's doing out is that it's printing out the memory location of the array. Essentially, it's telling me where it's stored in memory. This is a weird feature in Java. I have no idea why it does it like this. It's stupid, to be honest. Okay? I really have no reason to understand why it would do this in Java as opposed to doing what everybody wants it to do, which is print out the values stored in the array. But fortunately, there's a function for that already. There is a big giant. So remember how I was talking about how the math class has all this cool stuff in it. So math.pal likes to give you x to the nth power, right, or something like that, or math.square root to give you the square root, right? So just like math has a bunch of functions, we have a class called arrays that's actually quite useful. Arrays.minor. So there, and you just need to import it using java.util.arrays. But the first thing we're going to use it is to use it to print out our arrays. We'll learn how to do that on our own in just a second. But for right now, when I modify the array, I want to make sure you can easily see it. So arrays dot, so toString, and then whatever the number is. So arrays dot toString, and then whatever our variable is that our array is that we want to print out. So now that will print out 20 numbers. Let's go ahead and make it a more manageable 10 to look at, right? So there's 10 zeros. Okay, so that's how we print out our array. Oh, okay, this is starting to get annoying, right? So that's honestly to be honest though, that's the only annoying thing I find about Java, which is that to print it out, I have to throw it in arrays.toString. All right, so now let's go ahead and see what happens if we change some stuff. So to change some stuff like nums5, let's go ahead and change index 5 to 11111. Okay, so 5 ones in a row. Index 5 has 5 ones in it, so now we've got 0, 1, 2, 3, 4. Index 5 has 5 ones in it. Okay, remember, arrays start at 0. Okay, that's pretty cool. Let's go ahead and change it to 2. Boom, it changes to 2. Let's go ahead and put 2 at index 2, right? Okay, nothing too scary there. Okay, let's go ahead and see. Okay, what numbers can we put in here? So 0, right, is the first. So what happens if I try to put something before it, say at index -1? I get basically the error that will be the bane of your existence for the next week or so. Well, the week at least after you come out of spring break, which is array index out of bounds exception, which just simply means that you went out of bounds. Also, when this happens, read the error message, and it will tell you, like, arrays basic, that's the class I just wrote, right? I'm working in arrays basic.java. Line 13, it's telling me line 13 is where you went out of bounds. So that's the line you need to be aware of. Or around that line, or something you're using in that line is the issue, right? So, array index out of bounds. Okay, although you should be aware that if we were talking in Python, for those of you who took 1051, right, I can create an array like this, right, 1, 2, so a bunch of zeros. So this is just how it works in Python, although we call it a list in Python, right? In Python, I can say, hey, let's change that to 3, right? And that's what it looks like now. And instead, if I say -1 over here in Python, it doesn't crash. In fact, it changes the last value. In Python, it works a bit differently. Oh, that resolution is terrible. I'm sorry. Looks great on my screen. It'll look great on the recording. In Python, and maybe a couple other languages, I don't know, they'll let you know when you hit them. -1 is actually a valid index, which just simply means we're going to go through this array, or this list as it's called in those languages, in reverse. So, but in Java, it's invalid. Also invalid. So index 9 is the last value, right? So if I try to go to index 10, you might think that basically the array will be the Java will be nice and make it nice and bigger for you. But here's the thing about arrays. Once you create an array, or you create memory for it, its size is set in stone. Okay? You cannot change the size of an array. So let's go ahead and start so that's kind of the basics there. If I wanted to print out something specific, like if I want to print out a specific index, I would just simply do system.out.println nums, and then let's say I want to print out index 5. I just simply say nums5, and it will treat it like a single integer. It will resolve to a single integer, so I'll print out 2. All right. So generally, though, it's a pain in the butt to just manipulate these things one at a time. So instead, a lot of the times we use for loops, and for loops And this is why we see that for loops start with 0, because arrays start at 0. Okay? So what we'll do is that we'll go for int I is equal to 0. So right now what I'm going to do is I'm going to write a for loop, and all it's going to do is it's going to change the values of the array such that all the values basically all the values equal their indices. Okay? So for int I is equal to 0, I is less than, well, we had 10 right now, so we'll put 10 here. We'll figure out how to make that a bit smarter later. I++. So i's values is going to be, so int index is equal to I, right? And we also want value equal to I, right? So, bit redundant there. And basically, nums, we want to change the current index to value, right? It's super redundant there. We can, of course, shorten that, and we are going to, but it's easier to read the first time you see it if you do it like this. And what this does is that changes all the values. 0 has index 0, 1, 2 has 2, 3 has 3, 4 has 4, all the way up to 9. Okay, of course, though, if I change this to 20, it only goes up to 20. It only goes up to here, and then it doesn't change any of these values. They're all zeros because the default value is 0. Okay, so what's going on over here? Well, we go through the values one at a time, right? We go through i's going to be equal to 0, then it's going to be equal to 1, then it's going to be equal to 2, all the way up through 9, right? And then we say, I'd like to store value, which is going to be like something like 0, 1, and 2, or 3, in the index, which is going to be that same value. So we can actually shorten that to say, I'd like to store I in the ith index. Okay? So we can also do something like, maybe I'd like to store twice the value. So instead of storing 0, 1, 2, 3, 4, 5, I'm storing 0, then 2, then 4, then 6, then 10, right? I'm storing twice the value of I in the ith index, right? So, okay. It will get messy and hairy later on. So how in the world do I make sure that if I put in 20 over here, I get 20 over here? One way is to use something like a constant, like int, like final int size is equal to 20, and then you can just use size wherever you have an array. But honestly, that's a good solution, but it isn't the best solution over here. But basically now it will change with it. I mean, the other solution is to actually use something built into the array where you can ask an array what the size of the array was. Now, not every language had this. In fact, you would often have to pass the size of the array around in C a lot, which made it a pain in the butt. But Java, fortunately, because arrays are objects, they have stuff like this. You have nums.length, which gives you the size of the array. So nums.length is 20. Or it can be, so now I can do something of size of 100, and boom. Similarly, now that we know how to do a for loop, we don't need the arrays.toString anymore. We can write our own. We can do for int I is equal to 0. So for all the indices, that's a part of the reason why we use I as well. Not only it's short for int, but it's also short for index. So for each index I, from 0 to nums.length, excluding the nums.length, so basically for every single valid index that exists, let's print out the value that's stored on a separate line. And so now we store it on a separate line. So I'm going to stop the video and then restart it.